Okay, now let's do a dividing rational expressions. The very first thing you want to do, because if you were just dividing fractions that were numbers with no variables, it would be the same process in that it changes to a multiplication problem. My division changes to multiplication, and I flip my second fraction. Leave the first one the way it is. And now it's become a multiplication problem, so all we have to do is factor and cancel. So this guy's going to factor. This is a monomial. Here's another monomial. And then this guy's going to factor. Now we've got everything factored. Let's look at some canceling. Remember, you cannot cancel horizontally, only vertically and diagonally. So my y minus 2's can cancel. So left on the top, 4y squared times y minus 3. On the bottom, y cubed times y plus 5. Keep in mind we can keep canceling as long as I'm canceling factors, not terms. Factors are things that are multiplied together. So that's a factor, and all of that is a factor. This is a term, and this is a term because they're attached by subtraction. These are also terms, they're attached by addition. So these are factors, I can cancel them. It's going to leave me with a y on the bottom. When I am dividing like bases, my y is the base, I subtract my exponents, and the answer goes with in the denominator because that's where the highest exponent resides. Now, long way around that, if you ever forget your rules, if I've got my y squared over my y cubed, that would be a y times a y on the top, and on the bottom I'd have a y times a y times a y. 2 on the top, 3 on the bottom. Cancels, cancels. And notice that y is left over and it's in the bottom. Everything canceled out of the top, so that's a 1. And then a y on the bottom. If you had a y in the top, that would be wrong. All right, then back to our problem. There's my final answer and I'm done. Now keep in mind, if I were to try to graph this guy and graph this, I should see the same graph because these answers are just a different form.